exponential expression in one of the ways we added and then subtracted and then turned it into a fraction. The other way we subtracted, then added, then turned it into a fraction. So we specifically talked about we might not have the same process, but you have to follow the rules and get to the right answer. Okay. Another thing that I really want to make sure you guys understand is if you have a negative like this, do not do anything to move it to make it a positive until it would be your last step. One of the things that I have students do is they'll try to, like they would take this right here and be like, oh, now I'm going to shift this down here because it's a negative, and it causes like more steps than it needs to be. So this situation of either moving it to a denominator or moving it up to a numerator should be the very last thing you will do. Because ultimately, you might have to do something else with that negative, and maybe it's not a negative anymore, and you just created more work for yourself. Okay, so let's do a couple more examples. We've got some extreme exponents here on this back page. We've got two expressions here, 3x to the 7th times 4x to the 5th. I'm going to multiply the 3 and the 4, and I'm going to get 12. Multiply the coefficients. And then when I do x to the 7th times x to the 5th, I get x to the 12th. And that's my answer. So you multiply the coefficients, and then if they have the same base, you can add. If this was a y, then you would not have been able to add 7 and 5. You can only use the special shortcuts if they have the same base. Okay, let's go down here to number 2. I told you it was extreme. Like it wasn't false advertising. Hopefully yesterday's video helped you. It's going to help you with some of this. Kind of familiar, maybe? You guys did the ed puzzle, right? KK? I already know who did it and who didn't. All right, so the first thing I'm going to do is I'm going to distribute this 4 to each of these terms, to the 3, the x squared, and the y. So I'm going to get 3 to the 4th, x to the 8th, y to the 4th. Remember, when I'm distributing in here, I'm multiplying because it's inside and outside the parentheses. And then I just bring down the 2, x to the 3rd, y to the 7th. Can't do anything with that yet. My next step is going to be to simplify this 3 to the 4th. So I'm going to get 81, x to the 8th, y to the 4th, times 2, x to the 3rd, y to the 7th. So a lot of simplifying exponential expressions is rewriting the same thing over and over again and just doing one little step along the way. Now I've got kind of what I've had up here with number 1. I'm going to multiply the 81 and the 2. X to the 8th, x to the 3rd, y to the 4th, y to the 7th. And this is my simplified expression. I don't have any negatives. How are we feeling? Crystal clear? Vince, you okay over there? All right. Do you know anybody else going to Garin, or is it just you?
Nixon, but that's all I know.
Who?
Nixon, he's not on.
Oh, okay. my, I don't want to say favorite because I don't have favorites, but a student that I had last year who was really funny is at Garen right now. So, you want to look for him. Nice guy. Name's Finnegan. Do you know him?
Wait, what's his last name? Holden?
Uh-huh. He's funny, right? No, you guys are looking at me like he's not funny. He's a funny guy. How do you know Finnegan? Allie, why is your face all red?
I don't know him.
How do you know him, Madison?
I just know him because of Maggie's brother. I don't know him.
Oh yeah, he's friends with Jake because they were both on the same team last year. How do you know him, Brayden?
Baseball, and I used to hang out with him.
You used to hang out with him? Yeah. His friends were not nice to him when they found out he was going to Garen. They were not happy about it.
What's Garen?
Garen Catholic school. It's on, yeah. That's a lot, right? How do you know him? Okay. Number 3, we're going to do some division here. Okay, so I'm going to distribute first. Every exponent gets multiplied by a 2. Remember, there's secret 1 exponents hiding if you don't see them. So it's going to be 15 to the first power times the 2, so I get 15 squared m to the 6th n to the 8th over 5 squared m to the 4th n squared. I'm going to take these numbers and I'm going to actually square them. 225 m to the 6th n to the 8th over 15 m to the 4th n squared. I do have students that will try to do more than one step at a time. And if your brain can do that, what did I do wrong?
Isn't it 25?
It is 25, yes. If your brain can do more than one step at a time, by all means go ahead. But I can only do one at a time. Like that just works easier for me. So if I think I made a mistake, I can find it easier. Or you guys can find it for me, whatever. So we have this 225 and this 25. We can just divide those because that's a fraction is division. And I'm going to get 9. And then I'll do m to the 6th and m to the 4th. I subtract those and get squared. N to the 8th, n squared, I get n to the 6th. And so there's my final answer. So each of these becomes a separate division situation. Right? 6 minus 4 is 2, 8 minus 2 is 6. Addie.
So I know this isn't right, but why wouldn't you just subtract the 2 exponent from 15 and 5? Because they don't have the same base. Because, like, the second, when it was 15 to the second power and 5 to the second, why wouldn't you just subtract 2 and 2?
Yeah, because they don't have the same base.
Okay.
Because then if I was left with 15 and 5, what's 15 divided by 5? 3. So you can't, right? I mean, I guess you could do 15 divided by 5 and then square that. If you remember to square that, then you would still get 9. But, yeah, it's definitely all about the same bases. Okay, let's scoot back up here to example 4. This is a 2. I will never use a z as a base. It just makes things too complicated. I say that knowing that the practice I'm going to give you has z's on it. I apologize. I personally won't use them. What would you do first? How would you attack this one? There's so much happening here. What would you do first? Remember, we can all look at it differently. Find something that can be simplified and tell me what you would do. Hayden, what do you think?
I'd add that x on the end. I'd add it over to the negative 1.
So you would combine these?
Yeah.
So you would be left with 3x squared times y squared over 2x times 4y, because negative 1 plus 2 is 1, right? Good start. Would anybody have done something different? There's no wrong answers. Well, unless you're actually wrong, but like how you start it, there's not just one way. Addie, what were you going to say?
Well, I don't know if you could have done it, but I would have flipped it since you had a negative, but I don't think that. But except then I started thinking, and you wait till the very end.
You wait to the end to flip it, because you really only would have flipped this x to the negative 1, and that can get funky, right? Okay, so now I'm going to do some you can't add them, but you can multiply them. So 3x squared times y squared, we're going to run out of room, that's why I went over here, over 8xy squared. 8xy, what am I doing? Here we go. Okay. So I multiplied the 4 and the 2. X came over here, y came over here. Nice. I really only have a couple things left I can do. Nolan, what can I do here? Eden, what do you think?
You can subtract the bottom line from the top line.
Yeah. So 2 minus 1 is going to give me 1y. Because 2 minus 1 is 1. And it stays in the numerator because it's positive. If it was negative, it would maybe stay there and I'd have to move it anyway. All right, and I just have one last step. Addison?
Do you subtract the 8x from 3x?
Just the x's, right? We ignore the 3 and the 8.
Oh. Then yeah, subtract the x's.
Yeah, so 2 minus 1 is 1. So I'm going to get 3xy over 8, and that is my final answer. Nothing else can be simplified. I'm going to draw some arrows here. Make it super, super clear. Okay, next one.
You really have to bring other letters in.
Yep. Those are J's.
I'm gonna do one.
Is that a 0
Oh, it's
on
a
the
0, so
outside?
everything's gonna be 1.
Well, everything in the numerator is going to be 1, right? Is a 0. So that should alleviate some concerns. So I'm going to be at 1 over 2h to the negative 3, j to the 4th, k to the negative 2. All right, now I just have a couple things left I can do. I just have to do some rearranging. So if a term has a negative exponent, all you have to do is move it to the opposite location, right? So am I going to move the 2? Nope. Am I going to move the h to the negative 3?
Yes.
Am I going to move j to the 4th? How about k to the negative 2?
Yes.
Yes. So my final answer is going to be h to the 3rd, k squared, over 2j to the 4th. Because I just moved these up to put them in the numerator, so now they're positive. And that's why it's the last step we do, is we rearrange. Because you never know what might already be up there or not up there or down there. Okay, we're not going to do number 6. I'm going to pass out your practice. You guys are going to work for a couple minutes. I'll find a sweet Shaun White video. Show you. Maybe they have a Shaun White highlight. I don't know. Your basketball game today? Your basketball game today? Yeah. Okay. Who do you play? All right. Here or there?
Here.
Oh, that's nice. I know, not convenient. Thank you. Did I maybe miss anybody? You okay? Okay. Taking a little break? All right.